So let us try to understand topological sort. So what is topological sort? Suppose you have nodes U and V. There is an edge between from U to V. So in topological sort, suppose this is topo sort. In topological sort, U always comes before V. U always comes before V. For example, you have graph 5 over graph 5 4 2 0 1 and 3. Then this is the graph. So the possible top sort for this is 4 5 4 2 3 1 0. Let's check it. This is statement. There is edge between 5 and 2. There is edge between 5 0. Then there is between 2 3 3 1 4 0 and 4. Now you can see that there is an edge between 5 and 2. 5 comes before 2. There is an edge between 5 0. 5 comes before 0. 2 3 uh, 2 comes before 3 and 4 0. 4 comes before 0. 3 1 3 comes before 1. 4 1 4 comes before 1, right? So this is a possible topological sort. Okay, now topological sort is only possible for DAC. Now what is DAC? DAC is directed acyclic graph. Topological say that you have to comes before V, but if there is an if the graph is undirected, so you have edge between U and V, and this is undirected, so you can go from U to V also. So the this will contradict the statement you always have to come before V. Before V can become before U, right? You can reach from V to U, you can reach from V to U also, U to V, you can reach from U to V, and you also can reach reach U from V to U, right? So the topological sort is not possible for directed graph. For a cyclic graph, suppose we have cycle 1 2 3 1, right? Then 1 comes before 2 because there is a directed edge from 1 to 2, and 2 comes before 3 because there is a directed edge from 2 to 3. Now if there is a cycle, and you can see that for this condition from 1 to 3, from 3 to 1, 3 has to come before 1, right? So is it possible to place 3 before 1 and it follows the 2 comes before 3, right? So it also contradicts the statement you always have to come before V. So for a undirected and cyclic graph, it is not possible. So the valid possible the topological sort is possible only for directed DAG graph, directed acyclic graph. Okay, so let's try how the algorithm works. So we use DFS and stack, right? Why DFS? Let's see that how DFS works for it. DFS gives us all reachable nodes from node U, right? All reachable nodes from node U, right? If there is a node 5 and it is directed to 2 and 0, so if I call on DFS on 5, it will give to 0. It gives also it gives 2 and 0, right? It gives all the reachable nodes from that node. Okay, one thing is that clear. It gives all reachable nodes from the node. Now why stack? Suppose say we have again 5 2 0. There is edge between 5 to 2. So one of the possible topological sort for this is 5 to 0. 5 to 0. 5, there is edge between 5 and 2, and 5 comes before 2. There is edge between 5 and 0. So 5 comes before 0. Now let's take the stack. Now first we put its child. First we put its child into the stack. By how it can be done? By using DFS. We call DFS on 5. It goes to 2, then it goes to 0, right? Now first we put 0, then we put 2, then we put parent, that is 5. So if we pop out the elements from this stack 5 2 0, it gives the order that parent comes before child, right? Stack ensures that. Okay, so कंप्लीट ट्राई रन करते हैं एक बार, ठीक है? एक एग्जांपल लेते हैं, उस पर कंप्लीट ट्राई रन करते हैं, देखते हैं क्या हो रहा है. 5 4 2 0, then 1, then 3. Okay, this is the graph, right? Let's make the adjacency list of this. Adjacency list बनाते हैं. We have 0 1 2 3 4 5. No edge 2 के लिए क्या है? 2 के लिए है from 2 to 3, from yes there is only one from 2 to 3, then 3 के लिए only one, 4 0 1, right, 5 2 0. Okay, and let's maintain the visited array. Let's maintain visited array. 1 2 3 4 5 0 1 2 3 4 5, and mark all of them is unvisited. Okay, this is visited array. Now let's maintain the stack. Let's maintain the stack. Right, stack. Now first 0 is not visited, so we call DFS on 0 and mark it visited. Now for 0 there is no further edge after 0, so we push it into the stack. Now 1, similarly for 1 we mark it visited and call DFS on 1. Now there is no further edges, so DFS call stops and put it to stack. Now 2, mark it visited. Now DFS of 2, it calls DFS of 3 because 3 is not visited, so first put 3 then 2, right, and mark 3 also visited. Now 4 comes, 4 neighbors are 0 1, so 0 1 are already visited, 0 1 are already visited, so no further call. After calling the FS4 there is no further calls, so we can mark 4 as visited and put 4 into the stack. Now similarly for 5, all the neighbors are already visited, so mark it visited and put into the stack, right? So this is how stack build up, and we just maintain the answer and get out the elements from the stack, and that gives me 542310, which is a very topological sort. Okay, now what is the time complexity and space complexity? We use DFS. For a directed graph, the time complexity is v plus u, right? We are using because DFS. And space complexity is big O of n plus big O of n, because for the stack and visited array. Okay, so this is the TC and SC. So let's try to implement it. We have size of the adjacency list. We have a stack. We have visited array. Okay. Then we have to make answer also. Then we have to iterate all nodes from 0 to n. If not visited that node, then we have to call DFS on that node, right? We pass it adjacency list, st, visited array, that's it. After getting all the DFS calls, we have to make our answer by pop out the stack. So while stack not stack.empty answer dot push back st dot top, and we have to pop out st dot pop after inserting into answer, right? Then we just have to return our answer. Let's implement DFS function. Void DFS. It takes adjacency list. First is it takes node, then adjacency list, then it takes tag, and it takes visited array. Okay. Now first we visit that node. Visit of that node equals to 1. If yes, I will put it. That's visited at that node equals to 1. Then we have to call its neighbor auto it in pencil list of that node. If not visited that node, then we have to call DFS on it, comma adjacency list, comma st, comma visited. Okay. Now after calling DFS, we have to put it into this stack. St dot push that node. Okay. So that's the whole code. Let's check it once. Yes, this is correct. We pass it the right st dot empty. We have to top st dot top. Yes, this code is looking right. Int and node adjacency list, then stack, then visited array. Then visited node equals to 1, node id, device of id is, I think it works fine. Let's try to compile it. It works. It works. Yes, it works. So this is the code. Thank you for watching.